Good afternoon, everybody. My name is ajith-Venkatraman. I'd like to thank you for being here and evincing interest in AWS Storage Gateway. I'm the product manager for AWS Storage Gateway. I'm really excited to be talking about AWS Storage Gateway and how it can help you reduce capital costs and simplify your operations compared to traditional storage technologies. For the next 45 minutes or so, I would spend time explaining what AWS Storage Gateway as a concept is, the key use cases, the benefits, and focus more on Gateway-VTL, which was a new gateway type we launched last week. So before I go in, let's take a step back. What are the processes associated with traditional storage technology? You typically begin with capacity planning. So you really try to estimate what is the extent of storage you would require that you need to provision based on your forecast, based on your business growth, and based on what you have seen historically, and then have a capital outlay allocated with that, against that, so that you can procure the storage upfront, get it installed in your data center, and continue using it. Once it's provisioned and up and running, then you have a phase where you are addressing it, maintaining it, tending to disks, changing disks as they fail, and then once the maintenance mode is over, you get into the hardware refresh mode because every data center asset has its own age, and then you have to refresh the hardware before carrying on the cycle again to continue growing along with your business. That's not it. It carries across the various tiers of storage that you have: primary, backup, offsite backup, disk-based backup, tape-based backup. So fourfold, the same kind of work that you would address in terms of traditional processes and technologies. What's the challenge that I've heard from customers about this process? The process simply doesn't scale to make data hypergrowth. So what was the size of original mailboxes that we subscribed to? 5 megabytes? Now it's in gigabytes. What was the original digital pictures we were taking? Kilobytes? Now even iPhones can take megabyte level pictures. What was the original PowerPoint that we created? Kilobytes? Now it could still go up into gigabytes. So that's the data deluge we are talking about. And this process, what I hear from customers is simply does not scale to address data deluge. What do Amazon S3 and Glacier offer? Low cost, pay as you go, and pay for what you use. What's the benefit of this? So you only pay for what you use. You're not worried about underutilization. You are not worried about over-provisioning. And you pay for what you use. That means you don't have capital expense. The benefit to that is, now we all know storage cost keeps dropping quarter over quarter, year over year. Why should you pay upfront for storage that you want to use a few quarters down the line where the price for the storage is going to be reduced? So that is the benefit of the pay-as-you-go, low-cost, pay-for-what-you-use model. You only pay for what you use. Scalability with simplicity. Scale. What is the scale we are talking about? Amazon S3 stores 2 trillion objects and routinely peaks to million requests per second. And that's the scale we handle. And at that scale, we offer simplicity to you. You're not worried about provisioning. You do not have to be worried about hardware refreshes. The challenge about hardware refreshes is, as simple as it might seem, it is accompanied with data migrations, and data migrations are often risky, and also incur dual leases because you need to be having your primary and secondary as you're moving data on to a new box that you have bought. We take care of all that. So you do not have to worry about hardware maintenance. You do not have to worry about tech refreshes. You do not have to worry about data center provisioning. You do not have to worry about power, cooling, forecasting, provisioning, etc. Security and durability. Both S3 and Glacier are designed for 11 nines of durability. And we have standard AES encrypted algorithm for data at rest. So your data is secure as well as highly durable. So where does AWS Storage Gateway fit into this story? So the key value of AWS Storage Gateway is translating the benefits of S3 and Glacier, as I talked about in the previous slide, to on-premise traditional applications. So the AWS Storage Gateway is a virtual appliance that sits in your data center. exposes standard iSCSI interface so that your applications will not have to be rewritten to make use of the value proposition of S3 and Glacier. At the same time, stores data locally, as much data locally as required to meet your performance requirements. So the AWS Storage Gateway takes care of securely writing data to S3 while your applications can write using the standard iSCSI protocols. So we use standard SSL writing to AWS so your data is secure in transit, and S3 and Glacier both store data encrypted in standard AES-256 algorithm, so your data is secure at rest. We have three gateway configurations. Gateway stored volumes, gateway cached volumes, and we have the newest storage gateway edition, which we announced last week, Gateway Virtual Tape Library. So the gateway cached volumes and gateway stored volumes are block-based gateways. They expose iSCSI block protocols, so applications that can write or read iSCSI block protocols, they can mount iSCSI-based volumes, while the gateway takes care of writing data to Amazon S3. So in the next couple of slides, I'll focus on the use cases that can be used against the block-based gateways I talked about. The newest gateway that we added exposes a standard iSCSI-based virtual tape interface. So you can make use of a virtual tape infrastructure leveraging Amazon S3 and Amazon Glacier. I'll focus more on this as I move ahead. I'll focus in detail about what are the benefits of Gateway-VTL, how can you set it up, how can you use it with your backup applications, and how can you monitor it and manage it. So as I said, gateway cached volumes and gateway stored volumes are our block-based gateways. They offer iSCSI-based volumes that you can mount as standard iSCSI volumes in your application and continue using it. So what are some of the common use cases for these gateways? You can use them for offsite backup. And think of a case where you have remote offices. When you have multiple remote offices, the traditional processes I talked about, they get magnified. They get magnified because now you have to do the same for each and every location. The remote offices bring some unique challenges. First and foremost, there are multiple locations. Second is your IT team there is doing multiple activities, has multiple responsibilities, end user computing, application support, backup. So you have an IT team which is multitasking. At the same time, it is really, really hard to predict how your various different offices grow. Each offices might have a different growth pattern. And all these challenges, combined with the traditional processes, are eliminated by Storage Gateway when you use them for offsite backups. So what does the Storage Gateway do? So you have your production systems, you have the backup servers, and the backup servers can see these iSCSI volumes and use them as disk-based backups, whereas the Storage Gateway securely moves data to Amazon S3. So you do not have to worry about provisioning data center space for disk-based backups. You do not have to worry about commissioning a separate vendor for having offsite backups. Your IT team does not have to worry about provisioning data center space as and when your data grows. So you can seamlessly grow. You can seamlessly provision an integrated offsite and disk-based backup storage solution together. Here's another use case, departmental file shares. All the traditional processes that I talked about, from capacity planning to technology refresh, are applicable here. But it also has some unique challenges, because when you're talking of a file system, you need to have data protection, two types of data protection. One against local logical data corruption, like you use snapshots so that if people lose data, accidentally delete data, or it's local corruption, you can restore that data. Then you will still have to ship data offsite so that you are protected against localized data losses, which could be hardware failure or data center outage. By using Storage Gateway as a departmental file share, you eliminate the need, and all these, sorry, even before I continue, I want to also add that The snapshotting or replication or offsite protection, all these adds additional software cost to it. And when you start multiplying that across the various departmentals you have, there is an incremental cost to every department that you add across hardware, across software, across data center, across management logistics. Using Storage Gateway for file share use case, it simplifies the entire process of data production and file serving. So how do we do that? You can have a file share, a standard Windows or Linux server, mounting iSCSI volumes from the Storage Gateway, and expose CIFS or NFS interface to your clients. So your clients can make use of file shares, whereas a Storage Gateway moves the data onto S3 and gives you the ability to take snapshots. So this provides you the ability to give protection against accidental deletes of file or logical corruptions. Now you're no longer thinking, okay, what is the overhead on my file storage should I provision for snapshots? What if my RPO requirements changes? Because you pay for volume, you pay for snapshot. We no way enforce quotas in terms of snapshot. You can really have unlimited snapshot of your file data. At the same time, data is offsite because it's in AWS S3 and snapshots are there as EBS. So you do not have to think about having offsite data production strategy for all your locations. We simplify operations. Another cool use case about AWS Storage Gateway is you could use this for disaster recovery and data mirroring. So the Storage Gateway is not only is available as a virtual appliance that you can install on your data center, but it is also available as an EC2 ARMY. So you can load the Storage Gateway on an EC2 instance, and you can continue to use the Storage Gateway on AWS. So let's look at this workflow. So let's say you have an application, in this case, and it's mounted to an AWS Storage Gateway. It's writing data to it, and data is backed up into Amazon S3. You can take snapshots of it, and you can reuse the data for either data production or for repurposing simply by taking a snapshot of that volume and spinning off an EC2 gateway and connecting that snapshot, and you have a replica of the Storage Gateway now. So you have a similar setup as what you have on your on-premise environment on AWS. You can mount your applications on EC2. You can run your applications on EC2, connect them to the EC2 version of the gateway, and get running. This could be for disaster recovery, because if you are keeping your disaster recovery set up on warm standby, you do not need to have the full fleet of servers. You can just run minimum needed servers and scale up EC2 instances as and when required, but your data will be readily available for you to do that and make use of the cost benefits of disaster recovery on AWS. If you want to repurpose data to be distributed on AWS, you can still do that. So this is the newest gateway we announced last week, Gateway Virtual Tape Library. So we were offering block-based devices. And with Gateway-VTL, we offer virtual tape library, standard iSCSI-based virtual tape library. So that, let's take a look at the primary goal of Gateway Virtual Tape Libraries is to ensure that we simplify your long-term backup and archive solutions. So let's take a look at the traditional solution for long-term backup and archive. You have your production systems. There is a typical backup application. Based on the policies you set, weekly fulls, daily incrementals, monthly fulls, 2-year retentions, 6-year retention, 2 weeks retention, start taking backup. And we all know that the need to backup data is highest in the first few weeks since the backup has been taken. So we have a disk-based infrastructure to address backup windows and perform restores as and when required. After that period, what happens is when data no longer needs to be frequently accessed, you move that data to a physical tape infrastructure, stage it before being sent offsite for legal reasons, business reasons, compliance reasons, and just for corporate policies. What is the common complaint I hear about this from customers? Is the same complaints that I hear from traditional technologies: capacity planning, provisioning, maintaining, managing, and then hardware refreshes. So imagine you're a media company, and you have 100 terabytes of data sitting offsite. We all know that movies where 100 gigabytes are now in petabyte scale. Probably you're managing 3 times, 4 times the same volume of data in tapes as you were doing before. What about tape migrations? Imagine having to migrate 300 terabytes of tape from different versions of LTOs that have been published. The common complaint from customers is, I'm spending as much time with my infrastructure that is storing data that's infrequently accessed as the same time that I spend time attending to data that is on my primary storage, which is more frequently accessed. This is clearly not aligned to the goals of the business. And what about reliability and security of my archive? Imagine the same media company, and your director comes to you, and the studio head comes to you and says, hey, look, this great movie we made in the 1990s, let's remake it in 3D so that we can remonetize the existing content. At that point in time, the data directly translates to a monetary value. Imagine you try to do a restore, and you just miss 4 scenes in that, 4 frames in that. What is the time you spend to recreate those frames? What is the amount of cost? What is the opportunity cost of not getting to market on time? Right? Well, digital technology has improved so much that dinosaurs look prettier, but it's going to be a stretch to make actors who are 20 years older than what they were in the same movies appear the same. So these are the common challenges that I hear from customers who are talking traditional storage technologies for long-term backup and archive. How does Storage Gateway fit into the equation? You can seamlessly replace your physical tape infrastructure with the virtual tape infrastructure backed by Amazon S3 and Amazon Glacier. And you can simplify your operations and improve durability of your archive solution. Let me go through the benefits. So I said, pay as you go for what you use. So you're not paying for over-provisioning. I'm sure people here would attest to the fact that getting 100% utilization on traditional technologies is very difficult. You do not pay for underutilization. Minimize data center footprint. How cool would it be if I could take that huge physical tape library that is sitting on-premise, compact that into a pizza-sized box, and save data center space, repurpose that for future initiatives. Simplicity. Eliminate tape lifecycle management. You do not have to worry about migrating tape data. You do not have to worry about verifying tape data. You can focus your resources to where data access is. If people are accessing a set of data more frequently, focus there. If something is infrequent, you do not have to focus. We take care of it. Scale seamlessly. Archive is something which can really, really scale faster than what you would anticipate. A 4 terabyte data set, let's say an Exchange server, do a weekly full backup. At the end of the year, before you realize, that's 200 terabytes. So imagine if you say a corporate policy which just says, I need to retain it for 3 years. You're talking of a 4 terabyte data set which easily proliferates to 600 to 700 terabytes. Amazon Glacier scales, and we provide you a limitless collection. As I talk about the solution, I'll explain. Secure and durable. You do not now have to worry about missing data that's being archived, be it due to manual handling of data, be it due to durability of the solution. Glacier is designed for 11 nines of durability. Let me talk about the details of the solution. There are 3 components to this solution. The first one is the gateway appliance itself, which sits in your data center, exposes standard iSCSI-based virtual tape library protocol. So you get virtual media changes and 10 virtual media tape drives that you can mount as iSCSI devices to the client that contains your backup application. You also have local storage, just cache and upload buffer. I'll explain this in detail as we go through the steps of configuring the backup configuring the Gateway-VTL. The local disks are used for 2 purposes, primarily to buffer data that's being written to AWS and to give persistent performance, predictable performance to your backup applications. The second component of the solution is the virtual tape library. So the virtual tape library is similar to your physical tape library, which is sitting on-premise with all the virtual tape slots. So tapes, virtual tapes that are there in the virtual tape library are backed by Amazon S3. So when you want to retrieve a tape, the virtual media changer grabs the tapes and mounts it to the virtual tape drive, the same way as a physical tape robot would do, and you can read data from the virtual tape. The third component is virtual tape shelf. Each and every virtual tape library is integrated with the virtual tape shelf, where you can store data forever without the data that requires infrequent access and that requires long-term retention. You can store data forever in virtual tape shelf. So the virtual tape shelf is backed by Glacier. So just to reinforce, the virtual tape library is backed by Amazon S3. So when you move data from virtual tape library to virtual tape shelf, you can make use of the low cost of Amazon Glacier. So let me walk you through the steps of configuring the Gateway-VTL. I'll also talk about how you can monitor the gateway, manage the gateway, and some inputs on what kind of hardware specifications you could have. So gateway cache volumes, gateway stored volumes, we talked about it, and gateway virtual tape library. So you are presented with three options when you deploy the gateway. So we are picking gateway virtual tape library. You can run them on your VMware host, or you could run it on a Hyper-V machine. So for this configuration, I've picked VMware host. You need to provision on hardware which is capable enough to support the Gateway-VTL. The minimum requirements are 7.5 gigabytes of RAM, 7.5 gigabytes local working storage for the virtual machine, and 4 virtual processors. So this is the minimum requirement. So I'll talk for sample requirement where you could get better performance by using a better hardware box. So you've provisioned the virtual machine, you've provisioned the local hardware. You have to download the AWS Storage Gateway virtual machine. So this is a joke that we encountered. So we had people asking us, is this virtual appliance eligible for Amazon Prime free shipping? No, it's not, because you don't need it. It's a virtual appliance. Once it's done, here's the thing. You could have your virtual appliance in a region, and you can pick the AWS region you want to configure it against. For example, you have an office in the East Coast. You want to have your virtual tape library and tape shelf set up in the West Coast. You can still do that. So that gives you immediate offsite cross-zone data protection. Pick the names, time zones, standard media changer. You can activate the gateway. And next step you're asked is to provision adequate cache storage and upload buffer. So the purpose of the cache storage is to durably buffer data before it's being uploaded to AWS. It gives predictable performance to your backup application. So AWS storage is durable. So we know S3 and Glacier are both designed for 11 nines of durability. So in terms of cache storage, we suggest that you configure that in RAID so that you can offer better performance to your backup application and also protect against unplanned or unexpected data loss or hardware failure that could occur on your hardware that you have provisioned for the storage gateway. The upload buffer is used to stage data while it's being uploaded to AWS. And when we stage data, we create periodic restore points for the same reasons as to protect against unexpected failures. It is critical that you provision adequate working storage for the storage gateway, be it cache or upload buffer. Performance, durability is two reasons why we insist that adequate working storage is provisioned. Once you have configured local storage, you can set alarms. So we allow 2 levels of alarms. So one level, you could set that as a warning, and second as something which needs at most attention. So in this case, we've set 65 and 85%. So at 65%, you still get an email trigger, and 85%, you still get another email trigger. So you can set it up to whichever thresholds that you think are appropriate for your business. The same for cache storage. That was for upload buffer. Once this is done, we ask you to create virtual tapes. You can still go and create virtual tapes after the setup is over. There's a separate option for that on the console. So the capacities offered for the virtual tapes are 100, 200 gigabytes, 400 gigabytes, 800, 1.5 terabytes, and 2.5 terabytes. These are aligned to your LTO tape capacities. And the reason is when you have an existing workflow, we just want to make sure that you can continue to use your existing workflows by picking the same tape sizes that you're currently using. So the barcode prefix gives you an option to identify tapes that are probably associated with a business unit or with a company that you're servicing. So business unit A, business unit B, whatever name you want to give the barcode, you have given Amazon. Once it's done, it's simple. Now your tape drives have been automatically created for you. Your media changer has automatically been created for you. The tapes have also been created. Once these have been created, you can mount these as standard iSCSI devices on the client on which the backup software is installed. In this case, we are using a Windows initiator. So you can see all the tape drives that are mounted on the client as standard Windows devices, iSCSI devices, sorry. So your backup application starts detecting these devices, and you can see the tape drives and media changer detected by the backup application. So it's available in the console of the backup application. Next step is you inventory these drives to make sure that the virtual tape cartridges that have been loaded in those tape drives become available for your backup application for reading and writing. So you can see the barcodes that have been loaded in the virtual tape drives. So once this is done, so the barcodes are available. And I talked about virtual tape cartridges that you can create again. So you can see the button on top, create tapes. So you can create additional virtual tape cartridges depending upon your business needs. You can see the status of the tapes. You can also search for tapes to find them. These are tape cartridges that are available in your virtual tape library. These are backed by Amazon S3. They are available for immediate consumption. So if your backup application wants to read a tape that's available in virtual tape library, they can go ahead and mount them. It is similar to a physical tape library. Our virtual media changer grabs one of these tapes and mounts them to a tape drive. So I talked about virtual tape shelf. So if you're thinking of offsiting for long-term protection, how do I get the data which is there in my virtual tape library to a virtual tape shelf and leverage the low cost of Glacier, the security and durability, and have a bottomless, truly scalable archive? All you have to do is simply eject the virtual tape from your backup application. Once the virtual tape is ejected from the backup application, we move the virtual tape from the virtual tape library to a virtual tape shelf. Retrieval from a virtual tape, let me go to the retrieval part in the next slide. Once you do that, tapes, so you can continue to store as many tapes as you want in your virtual tape shelf. So I've moved the tape from my virtual tape library to virtual tape shelf. Now, how do I retrieve those tapes? How do I read those tapes? You can read those tapes by visiting the console and click Retrieve Tape button. And you can choose the virtual tape that you want to retrieve. You can search for the barcode that you want to retrieve. So for example, you have a file, and you think you need to retrieve that file. Your backup application catalog will provide you with a with the barcode of the tape that contains the file. You can search for the barcode on the console. Once that particular virtual tape is available, once you find that virtual tape, you click the Retrieve button on the virtual tape shelf console. The next question it asks is, which virtual tape library should I load it into? So here's the cool thing about this feature. So let's say I have a virtual tape library, which is, I have an appliance which is in East Coast. I have another appliance in West Coast. They are all mapped to the same virtual tape shelf. This is used by my editing department, and that the West Coast, the East Coast is used by my editing department, and the West Coast is used by my post-processing department. And all of a sudden, my teams feel that they will have to collaborate on the same set of files. You can use the virtual tape shelf to load the virtual tapes into either virtual tape library, which is in the East Coast or on the West Coast, and make it available to departments based on their needs. So I've walked through the steps of configuring a gateway, mapping a backup application against it, writing data to it, retrieving the data from virtual tape shelf, ejecting the data from virtual tape library to a virtual tape shelf. How do I monitor the storage gateway? So we offer multiple paths to monitor a storage gateway metrics. So you can monitor the storage gateway through CloudWatch metrics. You can monitor the performance, be it throughput, latency, the working storage usage, the upload buffer usage, and cache usage. So when I say throughput, so it could be throughput writing into the application, or throughput that the gateway writes into AWS or reads from AWS. That way, you will be able to really understand what is the throughput going into the gateway and what is the throughput that the gateway is writing into AWS or is reading from AWS. The same with latency. You can also monitor upload buffer usage. So we have provisioned X terabytes of, let's say 2 terabytes of cache usage. And you see that you're running out of cache. You do not have to periodically go and monitor that, but once you set up metrics and the associated alarms with it, you'll get notified so that you can continue to add cache as and when your workflows start growing. Let me show you this example. So this is a particular metric that I've picked, cloud bytes uploaded. So that means this is the amount of data that the AWS appliance is uploading into AWS. The storage gateway appliance is uploading into AWS. The statistics is sum, and the period is 5 minutes. So that means it's aggregating data points over a 5-minute period. So the value here is about 500 million bytes aggregated over 5 minutes. So if you want it in megabytes per second, you have to translate the bytes into megabytes and divide it by 5 minutes into 5 minutes multiplied by 60 seconds. So that reflects about 1.5 megabytes a second of throughput based on the numbers that are there. You can also set alarms against this. You see the option of creating alarms. So if you think that my AWS storage gateway needs to alarm me when it's uploading more than, say, 20 megabytes of data, you can go ahead and create those alarms. Now I talked about bandwidth and throughput. Is there a way for me to really limit how much bandwidth my storage gateway can read and write? Yes, you could do that. You could do that by throttling. So in the gateway tab on the console, so you have a rate limit on upload to AWS, rate limit on download from AWS. So in this case, you can go ahead, edit those limits, and say, OK, I don't want my storage gateway to be uploading more than 20 megabytes a second. If you want to throttle that, you can do it. So that if you want to, so finally, as I talked about performance, so I talked about the minimum hardware requirements that are required for the storage gateway. But what is a good hardware specification? So I'm talking of a sample hardware specification here. This is a specification that we have tested in our labs. And we've got 90 megabytes of write-read performance, iSCSI, that is writing into the gateway. 90 megabytes into the gateway, and about 55 megabytes the gateway writing into AWS. The hardware here, the cache and upload buffer makes a difference. So we have we used about 8 into 900 gigabytes of 10K RPM SAS drives with 1 gigabyte of NV cache configured in a RAID 5 with 512 kilobytes stripe size. So based on this, we were able to stripe evenly across these drives. equally split in cache and upload buffer, SAS drives, and we got 90 megabytes, 55 megabytes upload into AWS. So we also recommend that upload buffer and cache are physically separate disks so that you can maximize your performance, so that they don't interfere with each other's operation. Moving on to the critical piece, pricing. The gateway appliance is charged on a monthly basis. So the appliance fee is $125 per month per gateway. Virtual tape storage on US East is 1 cent per gigabyte. So for data that reads infrequent access but needs to be stored for a long, long time, you can make use of the low-cost scalability, security, and durability of Glacier at 1 cent per gigabytes a month. The virtual tape library storage for data that can be immediately accessed from your virtual tape library is 9.5 cents per gigabytes a month in US East. Retrieval from virtual tape shelf takes about 24 hours to retrieve from a virtual tape shelf before it becomes available to a virtual tape library. That is 30 cents per gigabytes for peak concurrent data retrieval in a month. Now, what does that mean? Say, for example, I begin by retrieving 100 gigabytes of data in a day, and it takes about 24 hours to be available. Your peak is set at 100 gigabytes. And from then on, every subsequent 24 hours, if you just retrieve 100 gigabytes of data, you will not be charged for it because you have already set the peak at 100 gigabytes. So once first tape retrieval is complete, you go on to your second tape retrieval. You do not get charged for it. So 100 gigabytes into 30 cents, $30. You pay for one tape, and every subsequent tape retrievals that do not overlap but are happening on every 24-hour basis, you do not affect your peak, so you do not pay for it. So for more details on the AWS Storage Gateway, you can go visit AWS Storage Gateway, aws.amazon.com/storage gateway. And I know that I stand between you and lunch, so I would like to wrap it up. I would say thank you. It's very simple. You could provision a host, download the software from the link console, AWS console, choose the configuration, cached volume, stored volume, virtual tape library, allocate the requisite on-premise storage, and get started. You do not have to go through the entire process that a traditional storage would require. I'm here, I'm hanging around. Thank you for your patience, and thank you for your time.